Level, University of Groningen, and on the big screen to our left, to your right, Professor Aurelie Lemmens, formerly Tilburg School of Economics and Management, now Rotterdam School of Management. Professor Jonas Andersson from NHH has chaired the committee. The committee has found the thesis worthy of public defense. The committee has now also approved the trial lecture that took place in this auditorium earlier today. So we now begin the second and final test of the PhD, the public defense. The proceedings will start with a 20-minute introduction by the candidate presenting his research, emphasizing the objectives of the study and its result. This will be followed by
the audience. This is a presentation of my dissertation. Predicting credit card delinquency, a fundamental model of cardholder financial behavior. This has a 20-minute time limit. I have a lot of slides, much to cover. So just telling you to be prepared that I will flip quickly through some of the slides and put more emphasis on some of the topics in some of the slides. So just be aware of that. It might be useful to pay attention to me more than the slides, and I will point out different things that you may want to keep an eye on. Okay. So, we will look at credit card lending introduction. We will go through the theory, where I will develop the behavioral model which will be used. I will talk about the methodology, specifying the model, the estimation of my proposed model, and the specification of the baseline models. And then we will get into the results with hypothesis tests and comparison of predicted performance of the proposed model versus the baseline comparison models. Okay, so just to give a quick layout of credit card lending, what happens when you use a credit card and you borrow on the credit card. This is you borrowing. Either you repay, nothing happens, all smiles, you don't put any interest maybe if you pay quickly and so on. But you may also have payment difficulties. You reach delinquency eventually. The debt is then sent to collection, and it is then collected, or they try to collect it, either in-house or through third-party collection. So the debt collection manner I will not be covering. And based on the developments in credit card scoring and the mental accounting field, these are my research questions. Do mental accounting concepts significantly explain credit card delinquency in a behavior scoring model? If so, does the mental accounting model outperform current machine learning algorithms when predicting delinquency? Okay, so we will use mental accounting concepts to construct a model, and then I will compare this model to current machine learning algorithms. Okay. Current meaning current in the industry, credit scoring industry. I will look at three mental accounting concepts: payment decoupling, decision-making ineptitude, and present bias. Okay, so these three mechanisms. Based on those, I will go through how I calculate the variables used to sort of measure this, and then hypothesize the effect it has on delinquency probability. Okay. So first we will try to look at the mechanism itself. What does it mean, and how does it affect delinquency probability? Okay. Payment decoupling. Decoupling means that the payment itself is not saliently associated with the utility. And this is viewed as an important attribute of credit cards. Actually, it's an attribute that is viewed as maybe sort of a positive of a credit card. We know that using credit cards as payment, it reduces the salience of the cost. See, remembering the cost of an item is harder when you use credit cards. Customers prefer to consume without thinking of the cost. And assigning purchases to different mental accounts even further decouples payment and utility. We can also look into the literature examining payment plans where consumers prefer payments coinciding with utility, such as loan structures, auto loans, mortgages, and so on. You want the payment plan to coincide with how the utility actually works for you. And payments not coupled with utility will be perceived as losses. Okay, so you actually feel that in a different way when it's not coupled with utility. Carrying substantial debt could be conducive to unrelenting credit finance consumption, given the value function shape. Okay, this seems like maybe a little bit advanced sentence, but what it means is that given the value function, prospect theory value function, that maybe when you are into this loss domain of actually carrying substantial debt, maybe that actually further instigates debt consumption. And decoupling as a psychological effect, it's a mental type of thing, is likely to vary. Okay, so we have this effect, which is fairly established for different sort of financial decisions. And we also know that it is an effect that is likely to vary. Okay, so illustrating the effect using a few equations. That's what the next step is going to be. Okay, just to try to make the isolate the mechanism and show what the effect of the mechanism is related to delinquency. Let's say we have a desired level of consumption. C star is your desired level, and you can finance this to reach desired levels of consumption by using debt financing. So CT is what you can afford on your own. DT is, for example, borrowing on your credit card to reach this desired level. Okay. So asserting that, then we can see that we will borrow to finance consumption if the value of continued consumption is higher than reducing consumption. So if you want to keep consuming at high levels, then you will borrow. Or the value of keeping high consumption is more than reducing consumption or not reaching the ideal levels. That's just what I'm saying there. Okay. So let's expand this a little. If we include the value of future payment, okay, so this is future repayment. And down here I have some explanations of what the symbols is. D is future debt, if you remember that. Delta, discounting factor of future debt. Lambda is some cost to borrow. R is a factor of intended payments. And then we have L and H indicating low and high repayment rates, and then an alpha is the decoupling factor, okay, alpha. So that is the one we're interested in now when we're talking about payment decoupling, the alpha factor. So, future repayment, and then looking at this is the next month. Okay, so let's say that you have actually financed consumption with debt. Then the next month, the decision expands to include repayment of past debt. Okay, so here you have the decoupling factor of the debt that you're owed, or you owe to the bank. And this is a low level of repayment, this is a high level of repayment. And this illustrates where the decoupling factor comes in, the alpha. Meaning that how decoupled the debt is from your current consumption will affect your decision to continue borrowing. Okay, so if you have a high or a low decoupling factor, if it's not decoupled, then you probably will start to pay down, right, at high levels. If not, then you will repay at low levels and you will continue to borrow. Okay. So, value of repaying decreases if debt is loosely coupled to current utility. Okay. Still extending this, not just for a past month, but for M preceding months. Okay, so this is just the same thing, just for M months. And where we have low repayment levels, here's the alpha decoupling factor. Here's high repayment levels, alpha decoupling factor. So you will continue to borrow over here if the value of continuing to borrow is higher than not. Okay? And the value of continuing to borrow will be affected by the decoupling factor. Okay, and also, this shows nicely what happens to debt revolvers. I won't say much more about that. And a weaker association between payments and utility will reduce motivation to repay. That is what I'm trying to illustrate here. So, the likelihood of delinquency increases as the rate of decoupling increases. So the more decoupled payment is from utility, the more likely it is you will continue to finance consumption by debt, and the likelihood of delinquency goes up. Keep in mind the relation between the decoupling factor and the repayment factors here. Okay, make a note of that. Decoupling factor and repayment factors. Moving on, decision-making ineptitude is the next theoretical mechanism. Looking at poor decision-making. And it has been shown to look like a personality trait. Holding debt itself is a pattern of dysfunctional behavior. And this is likely an enduring thing. All right. So that's pretty well established. Where does it come from the mental accounting framework? Well, it's using mental accounts itself. That is what decision-making ineptitude, what I've called it, because the more you use mental accounts to influence your decisions, those are heuristics, they're likely to be wrong, they are not rational and comprehensive evaluations and so on. So we will look at what happens if you have some sort of persistent habits. So your consumption is habitual. So your current desired consumption is a function of past consumption and past debt finance consumption. All right. So this H factor. H. This is pretty much the same model that we had. We can see here is the H factor, where it has your current consumption is influenced by past consumption, okay? And with M months of borrowing, this happens, that's what it looks like. And we can observe this habitual persistence thing through persistence of careless borrowing. Okay, so we will observe this effect not just through a month where the cardholder has borrowed a lot, but if he does persistently. That indicates that we can actually see this trait of persistence in poor decision making. Okay, and that leads us to hypothesis 2. The likelihood of delinquency increases as the rate of decision making ineptitude increases. Okay, so keep in mind the effects here. We're going to return to that when we look at the variables. present bias is, of course, well researched. It's something that is fundamental to mental accounting, where you have a high concern for immediate consequences. Okay, so foregoing immediate consequences and being patient, of course, is the opposite. And this is likely to affect delinquency. That has been related to other research, both surveys and others. And we return to our equations. Now we will focus on the discounting rate of future debt. So a higher discounting rate means that the value of future repayment is reduced. And if we sort of simplify, if we give the cardholder a rational decoupling rate, which is 1, and disregard differences in repayment rates, RL and RH, let's say they're the same, this simplifies. The higher concern for immediate consequences could be observed by spending patterns, so we're going to look at spending patterns, and if we see these spending patterns, then we observe the effect. And hypothesis 3 is the likelihood of delinquency increases as the rate of present bias increases. Risk aversion is tied to the utility maximizing framework through consumption smoothing, which is the traditional hypothesis of why you use credit cards. We won't say much about that. We will look at, okay, can we observe this effect? Is the cardholder actually trying to smooth future consumption? We're looking at financial risk aversion, which is part of the rational framework. And the likelihood of delinquency will decrease if you are more risk averse. All right. So those are the hypotheses. Looking at the data, this is data from a consumer credit card company, part of a bank. These are transactions from June 2008 to June 2011. 183 delinquent cardholders, 1,974 non-delinquent cardholders, of which 250 are randomly selected. Transactions are converted into monthly observations. Okay, and these data are filtered several ways. Most importantly, filtered out those that are delinquent within the first 5 months. I wanted a few observations of each cardholder. Filtered out inactive accounts, of course, irrelevant accounts, and non-matching accounts because they had to match credit and debit data. So I have cardholder information, both credit and debit data. Looking at the sample, I have a full sample, which I will use to estimate the model, but I will also have a training sample and a test sample of 107 delinquent cardholders and a test sample of 76 delinquent cardholders. And I will construct a 1-month, 2-month, and 3-month test sample of these. Okay, and then there are some class imbalance correction methods I used, versions of the training data, mimicking the test sample procedure. What's important here is that I remove the actual delinquent month, and then I try to predict delinquency the month before, or 2 months before, or 3 months before. Okay. Payment decoupling, that is tied to repayment levels. So payment decoupling is observed if the lagged repayment ratios, repayment in terms of balance, is significant. So lagged repayment. So not current repayment, that will be that will actually just show a rational cardholder, or in just variations within a month. But the lagged repayment variables, because the lagged payment should not actually affect current financial status. If it does, this shows actually the payment decoupling effect. Decision-making ineptitude, also the lagged borrowing ratios showing this persistence of habit. Okay, present bias, that one is pretty simple because it's just if you have accelerated spending after your paycheck, that shows that you are present biased because you're not able to just spread out your payments after you get your paycheck or the highest observed income, whatever it is. And then risk aversion, operationalized as debt clearing ability. That's just summing up quickly, skipping through that. It's a hierarchical logit regression, and I'm short on time, I'll just have to quickly go through this. It's a hierarchical logit regression. I won't talk so much about that. These are the lag terms, which are important, but I construct these lag terms with segments where the segment weights of the lags are assigned here, or the lag weights are assigned by segments, sorry. So it's there. This is the lag weight segment routine. Okay. So this is for the full model where the one lag weight is between 0.5 and 1, and the other is between 0 and 0.5, varying between that. So, okay, we assign these by segments. This is a metropolis within Gibbs estimation. Just diffuse priors, very standard. Individual level parameters vary to get heterogeneity. The posterior is this, so maybe that doesn't tell you much, but the full conditionals are here. You just iterate through those. And the lag weights are assigned through this and using a switching matrix. And then the random lag procedure, which I also implemented, which is maybe not that important, assigned so. So accept reject algorithm. Baseline comparisons is machine learning algorithms. In keeping with time, I won't go through much about those. Neural networks boosting algorithms, stacked ensembles in various methods using grid searches, ROC as a search criteria. Okay. Proposed model uses nearest neighbor to select cases and individual level parameters. And we don't need to look at the comparison algorithms. Final model, here it is. What we can say is that it outperforms other models with credit-only data and the more restrictive model structure. And we can see that the segment membership of lag weights is clearly assigned to delinquents and non-delinquents. You can see the pattern here. And also the lag lengths. Delinquents have higher lag lengths than non-delinquents, only one lag. And that means that we have support for hypothesis 1, 2, and 3. Hypothesis 4 is not supported, the rational model hypothesis. Predictive performance, I won't go through the whole table, of course, but this shows that the proposed model performs better than the comparison algorithms through several test and training samples. And I have support for my mental accounting hypotheses. That is one important finding. And predicting delinquency is improved using a theory-driven approach with a structural model rather than machine learning models. Might be because this better replicates the structure of behavior. Okay. So we actually model the histories and so on, and that helps a great deal. So those are my main findings. That is it. That is well more than 20 minutes, I think. Sorry about that. And now we have some questions.
Thank you for Thank you for the introduction. We will now soon turn to the opposition, which will be chaired by Professor Jonas Andersson. If there are any questions from the audience, our regulations dictate that we take opposition ex auditorio, as it's called. That will have to wait until the committee is done with its questions. I now turn the floor over to Jonas Andersson. All members will take part in the opposition.
So, thank you for the presentation and your trial lecture. We have decided to go through the thesis thematically and sort of start with Orly or Peter, and I will follow up with a few questions. And the first one we will start with are the research goals of your thesis, and I leave the word to Orly first. Go ahead. Go ahead.
Can we hear her?
She cannot hear us.
Can she not hear us?
I can hear you.
You can hear you. So, the floor is yours, or the air is yours, perhaps.
So I have to guess from the voice. I don't know if the voice is really you. Okay. Dear candidate, very nice to hear about your research and finally get a chance to meet you. First of all, before starting with the question, I would like to congratulate you on a fine piece of work. It was very important to read your thesis, and I wanted to add to that I particularly appreciate your efforts to incorporate insights from consumer research, in particular mental accounting, into some econometric models. I think you don't see that very often, and that's very impressive. I also like to be very much excited to tackle important challenges, in particular credit scoring, and we know that this has really, as you said in your earlier presentation, has a lot of impact on people's lives and also on them getting access to grants, for example, in some countries. So it's clearly a very important discriminating factors, and it's important that we get more insight into how can you better predict credit scoring without having too many algorithmic bias, as we call them nowadays. So good job on that. I'd like to start with a general question about the goal of your research and of your thesis in general. So actually, if I read your title, you actually put two interesting words in the same sentence. You talk about predicting and you talk about fundamental, which I think makes me think about theory. So somehow it feels that in your thesis you're trying to nicely combine the goal of trying to explain something that would be the theory part, and I guess you do that with the mental accounting theory, and the goal of predicting something else. This being said, I'm wondering to what extent this is something that's actually possible to do if you think about it. Predicting and explaining are two very different things, and they have different necessities. They require different specificities for models. So I would like to hear a little bit what's your thought on that question, and to what extent you think the different types of models you have in your thesis help you in your explaining or predicting things, and whether you should assess them in the same way.
Okay, thank you for your question. Well, difficult to answer your question. Whether or not my models or the thesis is capable of modeling theoretical constructs and testing theory, and also predicting. Is that the gist of your question, if I understand you correctly? And if that's possible at all for any type of model. Yeah, it's a good question, and it's what I tried to do in the thesis, incorporating mental accounting and sort of using that to guide the way the model is structured and so on. Whether or not it was successful, I leave up to the reader. What I think myself is that yes, we have very good machine learning and artificial intelligence algorithms which are good at predicting, which some of them are only used for prediction, and it's hard to incorporate or say anything about the theoretical mechanisms behind them at all. I still think that using some sort of theoretically inspired model, and that's why it's called a fundamental model, and not a structural model, strictly speaking. I think that in some cases, such as this, it will actually also help in prediction in that it describes the behavior itself, which you are actually using to predict delinquency. So that's why I think that using some sort of structure to understand the mechanisms will also help prediction. I mean, isn't that something that we've always had as a goal in econometrics and building good econometric models? Is that we first understand the mechanisms, or try to understand the mechanisms, describe them somehow theoretically, and then see if okay, is this a good understanding of the data and what is happening? I mean, the process which is creating these data, which you are observing. And if it is, then it actually should predict data or the outcome in a better sense. That is my perhaps misguided understanding or goal, and trying to approach this while pursuing both goals is problematic. Yes, some cases probably not useful at all, but I think in some cases, and maybe in this case, that it is helpful to actually inspire the model with some sort of theoretical mechanisms. So I hope that was some sort of a good enough answer.
Thank you for your answer.
So should I leave the word to Peter if Aurélie is finished with this part? Or do you have more questions?
I can add to me.
Okay.
Yeah. Is it working? Can you hear me already? Okay.
Yes.
Mr. Candidate, I'm impressed by the work you did. Your thesis is well written, and I'm particularly impressed by the way you make the relation between theory and the economic theory we have, the Taylor and the Kahneman and Tversky, that all works, and you now made it more explicit and you measure it. I think that is one of the big findings of your study, and you use that. And your answer may be yes or no, so this is very simple and short answer. My suggestion is that your definition of the research purpose, particularly how it is articulated in your abstract, is a little bit fuzzy, in the sense that what you want to do, your goal is to explain credit card delinquency. That's it. And you can do that in different ways. But that one model is better than another model is the outcome, is not the research purpose. And I suggest you, when you are going to publish some of your work, first of all, I suggest you to split it between the behavioral model and comparison with the machine learning models. So you have 2 papers out of 1 chapter. That's better, and it sells better. It's better for your career. But I think these are 2 different problems. Do you agree with my suggestion, yes or no? And if not, then please tell me and convince me.
I agree wholeheartedly, and that is actually what I've been thinking myself also, because that is I mean, the most natural extension of this is going in that path.
Yeah.
I mean, it's hard to, I mean, it was very difficult to write this as a well-organized, structured thesis, which reads well when you're trying to actually approach 2 different goals. Going further on down the road, then probably, yes, splitting it up is probably useful.
Thank you.
Okay, so I have a brief follow-up on this topic, and before I do that, I should also compliment you for your good work and a very interesting thesis, which spans a lot of. You must have acquired a lot of different type of competence in doing this, so it's not a trivial work at all. So my question also has to do with your research goal, and in a sense, the part where you are comparing your thesis or your own theoretical model with machine learning techniques. I find it very interesting to try to compare a theoretical approach with a completely or almost completely data-driven approach. However, it's also as said, a difficult task to do, because you need to sort of, to be completely fair with the comparison, you need to do the machine learning part perfectly. If you would like to argue that my model is better, then you need to explain that you have turned every stone and done your best with the machine learning methods. So I would like you to elaborate a little bit on your thinking there, and I should confess that I am fully aware that it's not possible to do anything perfectly, but I would like to know about your thinking.
Sure, yeah. Screen went black. Just give me a few seconds here. Click on the relevant slide if you'll let me. There we go. So these are the two slides. That slide actually comparing, or telling about the comparison algorithms. And when I first started changing up the thesis, adding this to it, realizing that okay, well, if I do this, then that will be a good test of my model, I thought. But then I was also anxious that, okay, when I press go here, is my model just going to be perform really poorly compared to the machine learning algorithms. As you have commented, explicated to me through the comments you sent, that maybe the thesis does not delineate properly the details of this process of working through the machine learning algorithms. Well, what I did first was I had used the Lessman article a lot, because it's a very good review where they actually they test all the algorithms on credit scoring and on the same data sets. They actually run all the models and they compare and they show what's good or not. So you get a good sense of, okay, these types of algorithms are the ones you should be using. That's why I use them. That was for application scoring. I also looked at, okay, which ones, are there any ones that are good at behavior scoring? That's just to get a sense of which ones I should be using. So I looked at, because of that, these, which you know, neural networks, boostings and ensembles and so on. XGBoost I added because, mainly because it's one that had performed very good in certain contests and so on. It's a newer type of boosting algorithm, so I wanted to add that. So that's a starting point. And then I started to train these and looking at, okay, how do I optimize, how do I give it the best sort of possible way to predict delinquency, which is well, different sorts of training data. Maybe I'm biasing it by giving it the same testing data that my model has. So I changed up that, so I have several versions of the testing data, I have several versions of the training data. I tried to imbalance correct it. I did grid searches, I did automatic machine learning just to try that. I really spent hours and days trying to look at different structures of just neural networks and adjusting the boosting algorithms to see if anything, if I could improve it. And even, I mean, no matter what I did, it showed that, well, even though the machine learning algorithm sometimes for different specifications of the training and testing data, my proposed model performed better. I mean, I spent as much, I did as much as I could. I mean, I did it by the book, and yeah, just, I mean, I threw all I had at it. In the end.
I believe you. I think that might be something also to think about, to articulate well when you try to publish, because I think that will be important, because it could be construed as sort of a negative result otherwise, that you have compared with something that is not.
I have some of the code if you want to see.
Yeah, not now. Okay, so we're finished on this point. I think we should move on to the theory section, and particularly the mathematical, or the equations with the utility comparisons that you made. And I think I am the only one who had some questions there, but you fill in if you want to. So if you could take up slide 9, perhaps.
Okay. It's hard to work with this screen shutting off.
Okay. We could just.
One of these?
It was the next, I think. That one. So I think this would be reasonably easy for you to answer, but I need to figure it out. I guess there is a typo with a delta instead of a d on top. Is that right? In the sum, in the equation. Should it be a d, t? I actually think it was in
yeah.
And I mean that was not an important point. I just wanted to clear it out. So you have used other notation in equation 2.
This is an artifact of me trying to use the insert function.
No problem. Yeah. No problem. So it should be dt. Then. Yeah. So my question had nothing to do with that to start with. It was I was a little bit confused by this. I think you have a good explanation, but you have a index t here. So consumption at time point t.
Yeah.
And say that t is equal to 10 now. Yeah. It looks to me like you are paying back from time point 1. Is that correct? Or because you say that it's future payment? Or am I misunderstanding something? You have this sum which sums actually from 1.
That future payment, yeah.
So
future payment, past payment.
Okay.
Yeah.
But if you look at the indices there, you actually pay back.
This is just for 1 month, so you're paying back for the months that you borrowed. So that's it might be easier to understand for m months of borrowing, because then you have borrowed for m months. You continue to finance your consumption with m months. So this is the m months of borrowing that you owe, and this is you deciding, okay, am I going to borrow now, and what is the cost of future?
I see. Okay.
Yeah.
Okay. Then I get it. Yeah. Good. My next question concerning those is a little bit, which I agree with Peter that you have a nice transition from your theory to the empirical models that you use later. But do you have any connection between the different quantities here in these theoretical models and the empirical models? Or is it, you admitted yourself that this is not a structural model you estimate, so that's fine. But is there any connection? I had some difficulties to sort of, what is R in the empirical models, or some corresponding quantity? Do you have anything thoughts about that?
Well, that is a point of critique that I will also agree with. Yeah. I mean, the connection between the equations and the variables maybe not that easy to see. For example, the decoupling factor is here, and having the point was having a high decoupling factor will lead you to repay at low levels, and vice versa, and that's why you observe this effect through the repayment levels. Then you get at the decoupling thing. Yes.
Okay. Yeah. Okay. So then we're coming to.
Orly has a follow-up, I think.
Oh, sorry, Orly. Go ahead.
So it's I hear myself. Could you sound less hard?
You're breaking up.
Yes, we hear every second word, approximately.
If you can reduce the sound a bit, because I hear myself.
Ah.
Just a little bit.
Okay, hold on. 5 seconds.
I think it's good. That's fine. Thank you. So actually, that's okay. I don't hear myself anymore.
Oh.
Oh, okay. I was maybe standing too close.
So I had a follow-up question based on your presentation and what we just discussed now 1 minute ago about this decoupling. So I understand that decoupling, in the way it has been tested in consumer research, is something that is imposed by the environment. So it's some kind of exogenous factor that's typical to a given context. For example, you're going to decouple payment from enjoyment of a specific activity. And that's not something that usually the user has impact on. So it's slightly different than the context here, at least in the way you operationalize the construct, where you actually derive the decoupling context from the user's behavior. So you're saying someone who hasn't repaid very quickly, delay the repayment is going to be considered as someone who has a higher decoupling than someone who repays directly. So somehow, by this operationalization, you do make a decoupling an endogenous variable. And why would that be a problem, I think? Because I can imagine there might be some kind of underlying factor that makes someone more likely to not be able to repay his debt, but also to therefore decide to decouple. Right? If you're a consumer and you know you have financial trouble, you might be tempted to postpone repayments, and very likely you're probably someone who has a high risk to be in delinquency in terms of repaying your debt. So to what extent the effect that you measure is really a causal effect, or just some kind of correlation? Can you comment on that?
Okay, yes. So your decoupling could be some sort of a endogenous thing, where there might be some other confounding variable which sort of is the cause of both decoupling and delinquency. Is that did I understand? Like, okay. I developed my looking at decoupling from the theory that I examined. I looked at how Prelek and Lowenstein talks about it, and in the loan and repayment type of experimental stuff, where they use or they actually try to describe decoupling as some sort of latent factor which explains why people will like this loan over that loan in terms of payment plans. So whether or not it is there's some endogeneity problems, yeah, probably, and there's probably correlations between the variables, like you said, like theoretically, at least between decoupling and this decision making using mental accounts and so on. But the decoupling theory that or research that I have looked at didn't use this as a individual specific variable, so not like a characteristic of the consumption situation itself, or a characteristic related to something else. They used it as a trait of the consumer, and that's how I'm using it. I mean, there's several versions of what they're calling decoupling, which is also an issue with using this theoretical concept. It causes some confusion, I think.
Thank you for your answer.
Yeah. Yes. I have one question about the theoretical part. That is about the fact that you mentioned on page 28 that you really appreciate when your model could include personal characteristics. And that is individual self-control and some others. But I miss many variables like family size, family income, not only income of the one who has the card. Someone may have, I think that you also mentioned it as one of your restrictions, may have different cards.
Several cards. Yeah.
Several cards. Age is important because that has to do with your life cycle, but what is my expected lifetime that I have. So these data were not available, or you didn't consider them?
Considered, yes. I would have liked to have more information about the person and household and so on. The data I had access to, there was, and I think I tried to explain this in this thesis, but it was there were several databases where the one they had was sort of customer-specific characteristics, what is your income, age, and so on. I didn't have any that you could tie to a specific individual. There's one restriction, so I only had fully anonymized data. And also, these data was, I mean, the database was quite poor. It was surprisingly poorly kept, the database. So most of that data was so old that I decided I wouldn't use it, actually. So, but yes, in a if you think about implementing this model in a larger framework in a bank, then yes, that would probably, you would include some of that, yeah. And then you could use a lot of data that you get from the application of the applicant or something like that you have in this one. But this was a purely behavioral model is what I tried to do.
Okay. May I continue with a question about segmentation?
Sure.
Usually in marketing we have now wonderful methods to segment the market, and not a priori, that was before, let's say, the 90s. And after the 90s we have latent class models, mixture models, and you segment the market by lagged variables. And first of all, I'd like to know what is the rationale behind that? What is your idea that you came up with the idea of having these lagged variables? Can you explain that to the audience, how you use that? And is it an idea, it's a suggestion, you can say yes or no again, to apply on your data are available and are appropriate for that, to apply, for example, latent class analysis?
Okay, good question. Let me pull up something from the model. Let's see. We have model specification. There's the project regression. And then it says that the lag weights, which I use to calculate for the lags, they are between 0 and 5, and 0, 5, and 1. And whether or not you belong to one or the other is based on segments.
But 0.5 is very arbitrary.
Yeah, they're both arbitrary.
Yeah. That's a priori segmentation.
Yeah. So, but this, you know, the lag weights, they vary. I just let them run, and then I see where they end up for the for these p's for each variable. so I have the individual level effects, the BIs, right? So I have, you could call it the varying slope model, varying intercept model, whatever you want to call it, the BIs. But then I wanted to include, I wanted to sort of separate how long or what the effect of the lags are. See if the model can actually find that. That is why I wanted to include them. And then I used the segment-based approach, sort of, well, inspired by the finite mixture model, I guess you could say, to find out, okay, how long or what is the effect of the lag going to be, these, and which card holders belong to which lag weights. I mean, what lag weights are given to each card holder. So then to make it simple, to actually be able to estimate the model, I had to split it into a segment-based approach. Okay, instead of letting everything vary. It wouldn't be, I don't think that would work at all with when you already have varying coefficients for individual heterogeneity. So that's why I specified it that way. So each lag weight can be different for segment and variable, and they vary between low and high. And this could be a 1, for example. This could be 0.01 or whatever, and then it's just assigned and then estimated. So the segment approach of lags was just to simplify estimation, and then as it happened, I realized that, okay, this is maybe a good way. It actually coincides nicely with the theoretical constructs that I'm testing. That this shows that, okay, when you're at this segment and these lag weights, it's actually, okay, well, here we're showing the effects of the mechanisms I'm proposing too.
And have you ever concerned hidden Markov in this case?
Yes. Why not? I mean, I think there are a lot of approaches you can take, but since this is the assignment of the lag weights and
but in a completely different way. But it's close to what you are doing, and it's much more formal and less arbitrary.
Yeah.
So, but that's for future research.
Yeah.
That would I answer if I were you.
For future research, yeah. Well, I like the. I'm almost self-taught in the specifying and estimating this Bayesian stuff, so I wanted to use that. And I think it works nicely with testing the theoretical model, and that's only why. And I've come across several different ways of maybe approximating this process. Also hidden Markov, but also actually constructing my own type of machine learning algorithm could be that could also be a possibility.
Anyhow, when you submit it to a journal, I think this is one of the questions you will return from the reviewer. So I'm helping you to.
Thank you.
To anticipate.
Yeah.
Thank you.
Yeah.
Okay. I think Aurélie has some questions about segmentation as well.
No, Peter, just to get more familiar, I think we can move to the specification part.
Okay. So then, please.
Okay. So I have a question about, this is something I wrote in the previous note, so part of the question won't surprise you that much. I have a question about the time varying variables in your model. So clearly in the econometric model that you're using, I can see all the black value of the same variable. That's clear to me. That was not clear for me all you did with machine learning models. So the first part of my question would be whether you'd be willing to clarify or to include the time-varying values of a given variable in your machine learning model. And then the second part of my question is more like some kind of reflection on the field, given that you know a little bit the machine learning world by now, and see, I would like to get your opinion on how you think the field of machine learning will be able to evolve in the future in incorporating those time-varying effects. Because you show in your thesis it's something important, it does matter, but machine learning models are usually quite poor at dealing with dynamic effects. So two things, right? The X variable that have time values, so T, but also the B that time varying. And in a machine learning model, that's something that has been, I think, understudied. So how do you see the field evolving? And do you have maybe some idea on how you could tackle that challenge to maybe improve those machine learning models such that they would beat your own model later?
Okay, yeah, so addressing first the lags and machine learning, whether I did that. I didn't, that's not in the thesis, that's not described. I did use lags in some sort of manner, and tried that with the machine learning models at some point. It's not included because it didn't work well. One of the problems is that the lags I calculate are based on the econometric model, right? So when you're running the econometric model, it calculates the lags for each person, and then the lag weight is individual almost, or well, at least segment based. So the problem is, what lag weight are you going to use for a card holder you don't know is good or bad? Which is why I use the nearest neighbor routine in conjunction with my own proposed model when I'm trying to predict delinquency. So that is sort of the issue I had with it, that if I wanted to do that with the machine learning algorithms, then I would already have had to be using my own model in the first place to use those lags. So that's why I did not do that.
If I can just interrupt here for clarification. How about just adding the lag X variable in your model and let the algorithm tell you what the weight of those variables will be?
Yeah, of course. Yeah, I could just add the lags. I mean, tell what the lag is. Yeah, I tried that also. That's just a simpler step, of course. I forget how it turned out, but it didn't turn out well. I'm not sure what else I could have done with including lags. Maybe some sort of genetic algorithm for calculating variables or lags or something, and so on. Well, dovetailing that into what could be done in the future, I think that lags, yes, is important. What my model shows, lags are important, and dynamics. But also, number two, structure, because I think one of the reasons my model performs better than the machine learning models is because they are starting at a higher level of stupidity, for lack of a better word. They don't know anything about what you're telling them, and my model, I'm already telling them that these are different customers and histories and so on, so they understand the structure of the data, versus I'm not telling that to the machine learning model. So I think that incorporating the structure of the panel data in some way and making the machine learning model actually tackle that explicitly, that is something I'm actually quite interested to do. Probably the first thing I want to do. And then the lag thing, it may be sort of a, I could tackle that by just using parts of my own model, modeling the lag in a simple way, and then in conjunction with a machine learning algorithm. So it would be a more stepwise approach, piecemeal, but then I could model the dynamics and the structure explicitly. If that was, I mean, I'm just thinking about what I would like to do here.
Very interesting. I think you should do that.
Thank you.
Specification. You use, in fact, pooled data because you have cross-sectional data, different consumers, and you follow them over time. And I think that you implicitly, maybe I missed it, but use a random coefficient regression model because you have these individual, So the beta case, the big beta case, are averages.
Yeah.
And again, it's a suggestion to give the range of values of beta, the big beta plus the small beta, for each coefficient, because they differ because of the heterogeneity. So the heterogeneity comes, in fact, in your model from two sources, namely the distribution around the beta, the big beta k, as well as what we discussed before, the lag effect. Am I right that you use that random coefficient model implicitly?
Yes.
You didn't mention it, I guess.
Hmm?
You didn't mention it in the text.
No, I mean, the hierarchical logic regression or hierarchical regression has, I mean, you call it the random coefficient model. It has, I try to stay away from words like mixing and random effects and sort of thing because it's used in so many different ways and misunderstood. But yeah, you're saying I should explicitly show the distribution of the aggregate betas and the individual level betas.
Yeah, that gives much more
Yeah.
information.
Yeah.
Yeah.
I did include
Yeah.
there's some plots from the individual level betas. That's it, but not the aggregates. I didn't have the distribution of those. No.
And you didn't apply any test to see whether data could be pulled over cross-sectional units? Or is that not necessary? Because what you do is in fact you're mixing up different segments and you want to characterize them by one parameter for each variable. Whereas in fact these are different segments and they all have their own parameters. And I think you should apply some test, chow testing or so, to see whether these parameters are more or less the same or not. So, again, to summarize my question, where are you pooling tests?
So you're talking about the distribution of the aggregate betas, right? Yeah. So the distribution would just be the distribution of draws, right?
Yeah.
Yeah. And I have what I show in the thesis is just the point estimate of the median, and then I forget if I put it. I should have put in anyway the standard deviations and variance. I think it's there. I hope so, but it could not be. But of course, yes, that should be included explicitly. The distribution of the aggregate betas and the individual levels. I have looked at the distribution of the individual level betas, but it would be so many, because you would have one distribution for each. So yeah. So I just have the point estimates of those graphed, like you see. But yes, the pooled aggregate betas. Yeah.
Okay, I have another question about specification, and you are already familiar with this question, but is that I doubt whether your variables that you include in your model, and they are summarized on page 54, payball, bail-in, cash ball, ink ball, that they are by definition, many of them are multi-collinear because you use the same variable one time in the denominator and another time at the denominator. Balance is everywhere, and when I returned and I also studied your various covariant matrix, I found a couple of high numbers. One was by hand 0.88, and my guess is that that is one of the reasons why your hypothesis number 4 is not supported. What I suggest you again to do is to leave out or to re-specify your variables. Then, okay, then you miss something, you give up the relation with the theory. But then you can say that some parts of the theory are really overlapping, which is also an outcome of your study. But this is built-in multicollinearity. And I really suggest you either to use another approach by redefining, for example, by factor analysis or similar technique to have more orthogonal variables, or to leave one or two of these variables out, or to redefine them. And then it may help you to get better results. But because your favorite model, that is your model in table 4.4, as I remember, has only one current effect. Lagged effects are significant, but the current effect is only one variable is significant. And that's not nice to see what you have done, and that is the result of your research. It's only one variable on page 40. What is it? 73, which is significant. That is value. What's your reaction on that?
Well, you point to maybe the two biggest weaknesses that the research has. For one, the theoretical elements and mechanisms aren't that orthogonal themselves.
That's
and the connection between them and the variables is also a bit hazy, somewhat. And thirdly, importantly, maybe that some of these variables, there's a lot of multicollinearity. And I take it you didn't, the VIF index wasn't comforting enough.
yeah, but the fifth is danger. So you have fifths of 4. And when you compute that, that means that one of your variables is related to the other 3, and the R square is 0.75, which is very high. So fifth is misleading. And some people say it should be lower than 10. Now that's ridiculous.
That's very high.
Then you have 0.9. But I think you should have much lower fifths. And you have fifths of 4 and higher, at least in some cases.
Yeah, I mean, yes, and it's the variables that you allude to also. Regarding using calculating with the one thing in the denominator one, the numerator in the other, and also, I mean, it's used often in like accounting research. You see this where they use more or less same the data in the numerator, denominator, and so on. Also, there is this discussion of okay, are they correlated, interrelated? These things. It depends on the variable, and of course, testing it explicitly and showing whether or not this is a problem. I mean, I guess I could take a route where adding or subtracting variables to show, okay, this is how much taking this variable out affects the others, and so on. I mean, that would be when you have this hierarchical logit with varying coefficients, and maybe that is the simpler way to show it, because the VIF index is, even though I have it for panel data VIF, it may not be totally reliable.
But I really suggest you to do some sensitivity analysis, and if it appears that you can demonstrate that one variable out of theory is in fact a composite of two other variables, then you have a really big contribution to all these people who say something about present bias and all these things, but don't measure it, and you measure it, so
Yeah.
you are stronger in that case. But again, this is a suggestion. Yeah.
Thank you. And that's also one of the challenges I had, because they don't measure it, and these are experimental effects with cute names and so on, but they don't measure them explicitly, like what does this actually mean, and you know, out of experimental context, how do you find this? How do you actually observe it in the real world? And also, what is the difference between these effects? I mean,
That's it.
Yeah.
That's exactly what I mean. Yeah.
And then that gives you a lot of problems when you try to apply it.
So that's the third paper.
Okay, I have one question concerning the model specification, and that is connected to the comparison with the machine learning techniques. Machine learning techniques is usually sold as prediction tools particularly when you have a lot of weak predictors, many of them, 50, 100, 500, and it helps in picking out those. So that's sort of the selling argument primarily for those methods. I would like you to put that into context of what you have done and in your comparison.
Yes. All right. So yeah, you're right. That's one of the advantages that you have with machine learning. You can actually set up the algorithm to choose, well, okay, what is the relevant data here, and then it actually learns, okay, it's this column, or variable, and so on, and then you can find functions of those variables, combinations, and so on. Like you could compare it to a factor analysis, I guess, just looking at what's important. And then they can actually make predictions based on that. And for application credit scoring, then that is sometimes the issue that they have to face with. There are hundreds of columns of information, and then you don't know what's important, and then you just you can apply a genetic algorithm or something that, or whatever, that chooses these variables, and it gives you a nice way of doing that. For behavior scoring and for my model, I don't have that many variables. I mean, so that is one of the advantages that I wasn't able to use for for my machine learning algorithms, of course, because I only had a limited number of data, which are the actual transactions. But yeah, if I, again, going back to if this was implemented into a bigger model, then that would maybe be one of the extensions, that if you combine my model with a machine learning model or whatever you do, you would have to deal with the number of variables and columns.
Yeah, and perhaps, who knows, that whether the outcome would be the same. Because then the comparison would probably be that you would like to have your model augmented with other variables, and you would like to compare it with machine learning methods with all those variables too.
Yeah.
So that's also the fourth paper, perhaps.
Yeah. Now, I think you're the issue of, I mean, I believe my model is good, regardless of the level of columns or the number of variables. Because if you think about it in this way, some of the newer credit scoring companies, technologies, fintechs, whatever you want to call it, they're incorporating a lot of data, different data that has never been used before for anything like it. For example, one company gives you a better credit score if you buy a cheaper brand of chocolate than another. You scan it and it updates your credit score and so on. So in that context, then the only good functioning model is their model, or whatever model they are using, and all other ones would probably not be able to incorporate it.
But you have some practical issues with logic regression if you have 500 variables. I think that's something.
Yeah, you would have to do something beforehand.
Definitely. So we should move on to estimation of the models, and I leave the word to Aurelie to start.
I have a question for you regarding the, actually we already discussed partially that question earlier because you showed the slide on this grid search for machine learning methods. So I was curious the extent to which you think the criteria that you use to estimate your models actually might have an influence on the performance of those models. So let me explain. In practice, what you're actually doing, you're trying to find the hyperparameters that maximize the ROC curve in a particular setting. And I guess by hyperparameter in your case, you basically mean the learning rate, but I'm not sure if this is what you mean, or if you also optimize the other hyperparameters, such as the number of nodes in the tree and so on. But to what extent is that really a good procedure, given the fact that you're going to evaluate your model according to multiple criteria, not only the ROC, but also other criteria, as we can see in your results section. So maybe there's a better way to do that. And then second of all, even though you do fine-tune your hyperparameter based on this criterion, still the loss function that the algorithm use is unrelated to the evaluation criteria that you're using in the last stage, in the last chapter. So, for example, the bootstrap algorithm is usually trying to minimize loss that relates to the specification rate, while in the evaluation part you are looking at the ROC and also other criteria. Somehow there is some kind of mismatch, I think, between the what you try to optimize in doing estimation, so both in terms of the hyperparameter and the loss function, and then how you evaluate your model in the end. What's your thought on this?
Okay, yeah, so I evaluate my models with a different metric than I train them with, right? Yeah, because I specify that I use the AUC as the only metric for choosing, or for the grid search, for choosing when does the grid search stop, what is it, okay, are these good models good enough, or so on, should it stop updating because it can't find any better suggestions for models. That is all based on the AUC. And I use different metrics to measure how good the model is, partial Gini and Breyer score, and also AUC. I did use other criteria also. I have to admit that I just followed in Lesmond that I used AUC as a search criteria, and then for evaluation that was based on also their overall. It's not a meta-analysis, it's just a very big analysis of all models actually, where those three are the best metrics to compare because you get a global, local, and a probability, like root mean error, or not root, but mean squared error type thing. So that's why I used them three, but yes, I could have also used more criteria to find optimal models. Although it's not mentioned in the thesis, but I did use other criteria, not the Breyer score, because that is, well, then I'd have to implement it myself. But just other loss criteria other than the AUC, just to see if that made any difference, but I did not use the partial Gini or the Breyer score when evaluating the models during training for grid searches. And yes, that is a
So to clarify, what did you optimize in the grid search? Which hyperparameter do you actually optimize? The number of iterations or also the other hyperparameters?
Well, for example, the learning rates and so on. But for the boosting of trees, maximum number of trees, if that was just, it doesn't really matter, just set it to max, or as many as you want. And then for the neural networks, of course, there's a lot more in trying to search. So there was several specifications of the number of neurons and layers and all that. How many layers, how many neurons, and yeah.
And so what's your thought on then the loss function itself? So not only the hyperparameter of the loss function?
Well, I can show you. Oops. If you want to see. This is sort of what I ended up with for that's the neural network. You can see the
so I can see that's the grid search for the hyperparameters. That's very nice. But I was curious to the extent to which you didn't look into the algorithm itself, whether you can actually tune the loss function to the problem at hand.
Yeah, no, I tried the different loss functions. I ended up just using
a negative binomial or something like that.
Just using the log loss, I think. I can't remember what I actually decided on.
The binomial loss. Yeah. Okay. No, because that would be something also to consider for future research, whether you could. I mean, if you want those models to do better, obviously that's the question.
Yeah.
You might want to consider using loss functions that are more in line with what you're trying to optimize.
Yeah. Well, I think I did. I tried several loss functions, especially for the neural networks. It was more sensitive to the loss function than the GBM.
Okay.
If I remember correctly. I didn't put anything in there about it.
Okay. Thank you.
Yeah.
Is this all about estimation? Okay. I have some questions about some outcomes. First, I'd like to know in table 4.2, there I observe that your left parameter is for lag balance is twice as high as the current parameter. And I think this, okay, but what is the rational, can you explain that? The left balance is much higher in absolute value than the balance value.
It goes to the structure of the lags, because the lags are a combination of several lags.
Yeah. But to say it in words, what does that mean?
Since the way I have, one weakness of the way I've structured constructing the lags is that I construct the lags in combining them, right? So there's a lot of information in the lag variable I construct because it goes further back, right?
Yeah.
So that's why it has a bigger effect, I think.
So the past is more relevant than the present.
Yes.
Okay, that's it. Yeah. And then I have a question: why do you have simple ratio variables, standardized payment variables, standardized variables, whereas you say on page 52 that you standardize all variables because you want to have more variation. Now, to my opinion, if you standardize variables, the variation is not diminishing or increasing. I don't understand that, but what I also do not understand is why you have 3 of these columns. What is the rationale behind that?
I wanted to show, I probably didn't need to, but that the estimates are different when you move from just simple ratios and then standardizing one of the variables to standardizing both or more of the variables, that there's a difference there. That's why I have the all 3. I mean, I could have just used the standardized variables all the way, probably. And then what I say, regarding what the standardization helps is, well, it doesn't fix lack of variation, and I think that formulation is easily, well, it's probably not perfectly formulated.
It's wrong.
The idea of standardizing the variables is only just to facilitate estimation, actually.
Okay.
Yeah.
But do you realize that some of your parameters even collapse in sign?
Yeah. From simple ratios to standardized
Yeah.
variables. Yeah. Keep in mind that these are the aggregate beta values. So that's why the tables themselves are a bit misleading in what they show. I didn't come up with a better way to illustrate what's going on, because you have these aggregate betas, and then what's really interesting, or what really matters, is the individual level betas, or what's behind the effect of delinquency, or where the main effects are.
Thank you.
Yeah.
A brief follow-up on that. You have only standardized your explanatory variables, right? So in fact, it is a different model, fitted. I mean, you have changed the relationship between the x and the y variables. Did you pursue this in your prediction comparisons?
Of which one's predicted better?
Yes.
No, in the prediction I only use what I call the full model. Yeah, because it was the one that was better when I estimated it. That's why. So that includes all the structure and the debit and credit data. So that's why I use that, and since it performed better in estimation.
The next